Before we fully jump into our study of a system of equations, I'd like to talk about graphs of a linear function. We've done this before, but we're going to do this now in various forms, especially slope-intercept form. And we're going to talk about standard form of a linear equation. So we are first going to understand and calculate the values for the slope of a line, and then given the slope and what's called the y-intercept, that means where the graph crosses the y-axis, we're going to write an equation from that, and then given an equation in slope-intercept form, we're going to graph it very, very easily. And then we're going to graph linear equations using what's called the intercept method. So quite a few things here, but very, very, very simple. The slope of a line through 2 points is defined as the difference in the y-coordinates divided by the difference in their x-coordinates. Many people think of this as the change in y divided by the change in x. But again, the difference in the y-coordinates. That just means y-coordinate, the point number 2, and the y-coordinate for point number 1, and x sub 2 minus x sub 1. So this 3 comma 1 might be considered point number 1, and this might be considered point number 2. But it really doesn't matter. They could be vice versa. We could do them backwards. I'm going to graph these two-ordered pairs real quickly. So 3 comma 1 is to the right 3 and up 1, so there's that ordered pair. And 2 comma negative 7 goes to the right 2 and it goes down 7. So to the right 2 and down 7. And I want to find the slope of the line that goes between those 2 points. You know, that was my attempt at. So that's a very steep line, and so it has a very drastic slope. My calculation can be done to find m, which is called the slope, by starting with the y value for point number 2. The y value for point number 2, that's a negative 7. And subtracting, so right here you're subtracting the y value for point number 1, which is a 1. And that difference is going to be a negative 8. If you need to, use a calculator. Then the x value for point number 2 is a 2. And then I'm going to subtract the x value for point number 1, which is a 3. And 2 minus 3 is a negative 1. But a negative divided by a negative is a positive 8. We can just leave it as 8, or 8 over 1. I want you to know, though, that that means that from this ordered pair, slope is defined as my change in y over my change in x. So from here, I could go up positive 3, 4, 5, 6, 7, 8. And then to the right 1, and I would see, again, up 8 and to the right 1, a positive 8 and over a positive 1, defines the slope of that line. Again, change in y over change in x. I want you to know that I didn't need to use this one as point 2. I could have started with this point as point 2. So for my y value, I could have started with this 1. So I could have calculated the slope by starting with the 1 here, the y value, and subtracting this y value. But when you subtract a negative 7, you add. So 1 minus a negative 7 is a positive 8. But if I did that, then when I do the denominator, I have to start with this x value and subtract this x value. So I have to take 3 and subtract the 2, and I get the same answer. So I need you to understand you can calculate the slope of a line in any direction as long as once you've made your decision, you stick with it. So if you wanted to start with this y value, that 2, and subtract that negative 1, go right ahead. But then you must start with this negative 5 and subtract that 4 in terms of the x value. So 2 minus a negative 1 is a positive 3. Negative 5 minus 4 is a negative 9. And when I reduce this, I get a slope that is a negative 1/3. Real quickly, let's look at that. So a negative 5 comma 2 is approximately to the left 5 and up 2. So left 5 and up 2. I'm going to go 1, 2, 3, 4, 5 and up 2. And then 4 comma negative 1 is to the right 4 and down 1. So right there. So this line, different than the last line, is a negatively sloping line because it goes from upper left to lower right. The last one went from lower left to upper right. So this is a negatively sloping line. This negative sign right here can belong to the 1. And then if so, the 3 would be positive. So we could say, let's go down 1 into the right 3. And we could go down 1 into the right. It's probably supposed to be 1, 2, right here. And down 1 into the right 3. Or the 1 could be positive and the 3 could be negative. So we could go, let's do this in red. We could go up 1 into the left 3, and up 1 into the left 3, and up 1 into the left 3 to represent this slope of a negative 1/3. Now we tend to put that sign in front of the fraction, but please know that that sign belongs with one of those numbers in the fraction. All right, what happens when we have y values that are the same? So m equals, so y sub 2 minus y sub 1. I think I'll just go ahead and call this y sub 2 minus y sub 1. Then x would be a negative 3, and I'm going to subtract 4. But in the numerator I have 0, and in the denominator I have a negative 7. If I look at the graph of these two lines, they have the same y value. So one is to the right 4 and up 7. I'm just going to put 4 comma 7 here. And the other one is to the left 3 and up 7. So I'm going to put a negative 3 comma 7. So the slope of this line is 0 because it's a flat line. And that makes sense that there is no slope. It's kind of like walking on the ground, level ground, like in your house. The slope of the floor in your living room should be 0. Hopefully it's not sloped. And it causes you no effort at all to do that. But this one, remember the slope is found by taking the change in y divided by the change in x. I'm going to go with the 8 first and subtract a negative 3. That'll be 11. But if I go with this 8, I got to start with this negative 5 and then subtract a negative 5 from the other. And this one is 11 divided by 0. Oh man, you cannot divide by 0. This is called an undefined slope. If we took a look at a picture of this one, they both have x values that are a negative 5. One of them you go to the left 5 and up 8, and the other one you go to the left 5 and down 3. But the graph of this line that goes through those two ordered pairs is this vertical line. And we often say that the slope of this line is undefined because it's like a rock climber. Man, nobody can climb a vertical face unless they have ropes and crampons and all that. Anyway, an undefined slope is a vertical slope. Now let's look at how we came up with this slope equation, and then we're going to take a break. So let's turn the page, and I want to represent this equation as a picture again. I almost wish I hadn't chosen red, but I'm going to stick with it. And I'm going to pick an ordered pair here that's called 0 comma b. And then I'm going to pick an ordered pair out here that's called x comma y. And I'm going to draw a straight line through those ordered pairs. So there we go. And then I'm going to, from this statement that we just represented, I'm going to write the slope of this line that I've graphed here, but in terms of letters. So the slope is to take this y value and subtract that y value. I called that b because that's called the y-intercept, and that's what we often call the y-intercept of an equation. We call it the letter b, and the x value at that spot is 0. So I haven't gone anywhere in this direction, and I'm up to b here. Now I'm going to subtract their x values. So I'm going to take this x and I'm going to subtract this 0. And what I have downstairs is just x. I want to solve this equation for y to get this in what's called slope-intercept form. So I'm now going to multiply both sides of this equation by x. So I'll have mx on the left and y minus b on the right. Again, I'm trying to get y all by itself so I can graph this equation. And what I'm going to do is I'm going to add b to both sides. And I have y all alone on the left side, and it's equal to m times x plus b. And what this means is if I have an equation like y equals 2x plus 7, it means that the slope of the line is the number in front of x, that m value, because we developed this from the slope equation. And the number, the 7, is the b value. It's called the y-intercept. And I could graph this knowing the slope and the y-intercept, just like in this problem that I'm going to do in a minute. I know the slope and I know the y-intercept. I'm going to graph it and I'm going to write the equation from this model. We're going to come back in our next segment and we're going to use y equals mx plus b, which is slope-intercept form of a linear equation, and we're going to graph from that.